There is no blanket code prohibition against installing receptacles above suspended ceilings. However, the National Electrical Code, or NEC, does outline specific requirements for such installations to ensure safety and accessibility. NEC 300.22c addresses accessible receptacles. Receptacles installed above suspended ceilings must be accessible. Accessibility is typically achieved by being able to remove a ceiling panel. There are exceptions. Firstly, if the suspended ceiling is less than 2.74 meters, or 9 feet above the floor, the accessibility requirement may be waived. Secondly, if the receptacle is part of a lighting fixture or fan, it is also exempt. Thirdly, if the receptacle is installed for a specific purpose, such as powering a projector or other equipment, it may also be exempt from the accessibility requirement. NEC 314.29 covers suspended ceilings. Receptacles installed above suspended ceilings must be securely supported and enclosed in a box or raceway. The box or raceway must be installed according to the manufacturer's instructions. This ensures the receptacle is properly mounted and protected from physical damage. NEC 410.24b pertains to dwelling units. In dwelling units, receptacles installed above suspended ceilings in bathrooms, kitchens, and other wet locations must be ground fault circuit interrupter protected. This is because of the increased risk of electrical shock in wet environments. NEC 410.24c addresses other locations. In other locations, receptacles installed above suspended ceilings must be ground fault circuit interrupter protected if they are located firstly within 1.83 meters or 6 feet of a sink or other water source, or secondly in a location where water is likely to be present, such as a laundry room or a utility room. This is again due to the increased risk of electrical shock in areas where water is present. Therefore, while not explicitly forbidden, installing receptacles above suspended ceilings requires careful consideration of these NEC requirements to ensure safety and compliance. Let's elaborate on NEC 300.22c, focusing on the accessibility aspect. The requirement for accessibility is rooted in the need to perform maintenance, inspections, and repairs on the receptacle without disrupting the entire ceiling system. Imagine a scenario where a receptacle above a suspended ceiling malfunctions. Without easy access, diagnosing and fixing the problem would become significantly more complex and time-consuming. Removing multiple ceiling panels, potentially damaging them in the process, would be necessary. The exception for ceilings less than 2.74 meters or 9 feet high acknowledges that accessing receptacles at this height is generally easier, even without removing a panel, often using a step stool or ladder. This reduces the need for strict accessibility via removable panels. The exceptions for receptacles that are part of a lighting fixture or fan are based on the fact that these devices are already designed to be accessed for maintenance and replacement. The receptacle is simply integrated into a component that is regularly serviced. Similarly, receptacles dedicated to specific equipment, like projectors, are often installed with a defined maintenance plan in mind, making dedicated access provisions more practical. Now let's delve deeper into NEC 314.29 and the importance of secure support and proper enclosure. The requirement for secure support ensures that the receptacle is not simply hanging by its wires. This prevents strain on the wiring connections, reducing the risk of loose connections, arcing, and potential fire hazards. The specified box or raceway provides physical protection to the receptacle and its wiring. It shields them from dust, debris, and accidental damage that could occur above the ceiling. Using a listed box or raceway, installed according to the manufacturer's instructions, is crucial. This ensures that the components are suitable for the intended application and provide the necessary level of protection. Moving on to NEC 410.24, specifically the ground fault circuit interrupter protection requirements. Ground fault circuit interrupter protection is a vital safety measure in areas where there is an increased risk of electrical shock. A ground fault circuit interrupter device constantly monitors the current flowing through a circuit. If it detects any leakage current to ground, even a very small amount, it quickly trips the circuit, cutting off power and preventing a potentially fatal shock. In dwelling units, the NEC mandates ground fault circuit interrupter protection for receptacles above suspended ceilings in bathrooms, kitchens, and other wet locations due to the high likelihood of water exposure. Similarly, in other locations such as commercial buildings, ground fault circuit interrupter protection is required for receptacles within 1.83 meters or 6 feet of a sink or other water source, and in areas where water is likely to be present, such as laundry rooms or utility rooms. These requirements are based on the understanding that proximity to water significantly increases the risk of electrical shock. It is important to note that the specific requirements for receptacles above suspended ceilings can vary depending on local codes and regulations. It is always advisable to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes. Furthermore, it is crucial to use appropriate wiring methods and materials when installing receptacles above suspended ceilings. Conductors must be properly sized for the intended load and protected from physical damage. All connections must be made securely and insulated to prevent shorts and ground faults. The use of flexible metal conduit or similar approved wiring methods is often recommended to provide mechanical protection and allow for easy movement and adjustments of the receptacle. In summary, while installing receptacles above suspended ceilings is not inherently prohibited by the NEC, it is subject to specific requirements designed to ensure safety, accessibility, and code compliance. These requirements cover accessibility, support, enclosure, and ground fault circuit interrupter protection, and vary depending on the location and application. By carefully adhering to these requirements and consulting with qualified professionals, you can ensure a safe and compliant electrical installation. The NEC, or National Electrical Code, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by states and municipalities as the basis for their electrical codes. The NEC is not law itself, but it becomes legally binding when adopted by a jurisdiction. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. The NEC is revised every 3 years to keep pace with technological advancements and address emerging safety concerns. It is essential for electricians, electrical contractors, inspectors, and other professionals in the electrical industry to stay up to date with the latest edition of the NEC. Ground fault circuit interrupter devices are designed to protect people from electrical shock by detecting ground faults, which occur when current leaks from a circuit to ground. A ground fault can happen when a person comes into contact with a live wire and a grounded object, such as a metal pipe or appliance. A ground fault circuit interrupter device works by monitoring the current flowing through the hot and neutral wires of a circuit. In a normal circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. However, if a ground fault occurs, some of the current will leak to ground, causing an imbalance between the hot and neutral currents. When a ground fault circuit interrupter device detects this imbalance, it quickly trips the circuit, cutting off power and preventing electrical shock. Ground fault circuit interrupter devices are typically installed in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. They are also required for receptacles that serve countertop surfaces in kitchens and for receptacles within a certain distance of sinks and other water sources. There are two main types of ground fault circuit interrupter devices: receptacle type and circuit breaker type. Receptacle type ground fault circuit interrupter devices are installed in place of standard receptacles and provide ground fault circuit interrupter protection only for the specific receptacle. Circuit breaker type ground fault circuit interrupter devices are installed in the electrical panel and provide ground fault circuit interrupter protection for the entire circuit. When selecting a ground fault circuit interrupter device, it is important to choose one that is rated for the appropriate voltage and amperage for the circuit it will be protecting. It is also important to ensure that the ground fault circuit interrupter device is listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. Proper installation of ground fault circuit interrupter devices is essential for their effective operation. The devices must be installed according to the manufacturer's instructions and tested regularly to ensure that they are functioning properly. Testing can be done by pressing the test button on the device. If the device trips, it is working correctly. If it does not trip, it should be replaced. In addition to ground fault circuit interrupter devices, there are other types of safety devices that can help protect people from electrical shock, such as arc fault circuit interrupter devices, or SIs. Arc fault circuit interrupter devices are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between two conductors, creating a spark or arc. This can happen when wiring is damaged, loose, or corroded. Arc fault circuit interrupter devices work by monitoring the electrical waveform of a circuit. When an arc fault occurs, it creates a distinctive waveform pattern that the arc fault circuit interrupter device can detect. When an arc fault circuit interrupter device detects an arc fault, it quickly trips the circuit, cutting off power and preventing a fire. Arc fault circuit interrupter devices are typically installed in bedrooms, living rooms, and other areas where people sleep or spend a lot of time. They are also required for circuits that serve lighting and receptacles in dwelling units. The NEC requires arc fault circuit interrupter protection for all branch circuits that supply 120 volts, single phase, 15 amps and 20 amps outlets installed in dwelling units. This requirement has been expanded over the years to include more areas of the home. Both ground fault circuit interrupter and arc fault circuit interrupter devices are important safety devices that can help protect people from electrical shock and fires. It is important to understand how these devices work and to install them properly to ensure their effective operation. Another important aspect of electrical safety is proper grounding. Grounding is the process of connecting electrical equipment and systems to the earth. This provides a path for fault current to flow back to the source, which helps to trip over current protection devices, such as circuit breakers and fuses, and prevent electrical shock. There are two main types of grounding: system grounding and equipment grounding. System grounding is the process of grounding the electrical system itself, typically at the service entrance. This is done by connecting the neutral conductor to a grounding electrode, such as a ground rod or metal water pipe. Equipment grounding is the process of grounding the non-current carrying metal parts of electrical equipment, such as appliances, tools, and enclosures. This is done by connecting these metal parts to a grounding conductor, which is typically a green or bare wire. The grounding conductor is then connected to the grounding electrode. Proper grounding is essential for electrical safety. It helps to prevent electrical shock, reduce the risk of fire, and protect electrical equipment from damage. All electrical equipment and systems should be grounded in accordance with the NEC and other applicable codes and standards. In addition to grounding, proper overcurrent protection is also essential for electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. An overload occurs when too much current flows through a circuit, causing the wires to overheat. A short circuit occurs when there is a direct connection between two conductors, bypassing the normal load. Overcurrent protection devices work by interrupting the flow of current when an overload or short circuit occurs. Circuit breakers are resettable devices that can be tripped manually or automatically. Fuses are one-time devices that must be replaced after they have blown. When selecting an overcurrent protection device, it is important to choose one that is rated for the appropriate voltage and amperage for the circuit it will be protecting. It is also important to ensure that the overcurrent protection device is listed by a recognized testing laboratory such as Underwriters Laboratories or all. Proper installation of overcurrent protection devices is essential for their effective operation. The devices must be installed according to the manufacturer's instructions and tested regularly to ensure that they are functioning properly. Regular inspections of electrical systems are also important for maintaining electrical safety. Electrical systems should be inspected periodically by a qualified electrician to identify any potential hazards such as damaged wiring, loose connections, or overloaded circuits. During an electrical inspection, the electrician will typically check the following things. Firstly, the condition of the wiring and connections. Secondly, the operation of overcurrent protection devices. Thirdly, the grounding system. Fourthly, the presence of ground fault circuit interrupter and arc fault circuit interrupter devices. Fifthly, compliance with the NEC and other applicable codes and standards. Any identified hazards should be repaired or replaced promptly to prevent electrical shock, fires, and other electrical accidents. Electrical safety is a shared responsibility. Everyone should be aware of the potential hazards of electricity and take precautions to prevent electrical accidents.